So let's dive into Stephen Hawking's final and maybe his most provocative book, The Grand Design. He and Leonard Mlodinow decided to take on, well, the biggest questions imaginable. We're not just talking about the universe, we're talking about existence itself. And we're going to walk through the bold and pretty controversial answers they came up with.
I mean, seriously, think about these questions. Why is there anything at all? Why are we here to even ask that question? These are the fundamental mysteries, right? And the book just jumps right in, getting to the heart of what humanity has been wrestling with for thousands of years. But it starts with a pretty audacious claim. Wow. I mean, that's the opening shot right there. A bold declaration that the old ways of thinking are just obsolete. That science, and physics in particular, has picked up the torch in our quest for the ultimate answers. It's such a powerful statement, and it really sets the stage for everything that's about to come. Okay, so, if philosophy is out of the picture, where does that leave us? Well, the book argues that it leaves us with the laws of nature. This is the new foundation, the new ground upon which we have to build our entire understanding of everything. So let's actually trace this incredible shift in how we think. For most of human history, we didn't look for laws, we looked for gods. We saw divine hands at work behind every storm, every sunrise. But then, something started to change. A totally new way of seeing the world began to emerge. What's so fascinating here is the massive shift in control. In that mythical view, we're basically at the mercy of some moody cosmic wolf, and all we can do is bang pots and pans and hope for the best. But in the scientific view, understanding the laws gives us the power of prediction. The universe stops being this place of pure magic and turns into a place of reason. And this whole revolution in thinking, it really got its start right here, in ancient Ionia. Thinkers like Thales of Miletus were some of the very first to float this wild idea that the universe wasn't just chaos, but that it was actually governed by consistent, understandable principles. They started replacing gods with logic. This timeline just lays out that long journey so well. It all kicks off with that little spark from Thales, then it builds with Pythagoras finding actual math and music, and then Aristarchus has the nerve to suggest we aren't the center of everything. But of course, it was Newton who really brought it all home, showing that the same exact laws that make an apple fall also keep the moons circling the Earth. All of a sudden, the universe wasn't just mysterious, it was knowable. But okay, just when we start getting comfortable with this idea of a knowable, solid reality, Hawking throws a huge wrench in the works. What if our reality isn't the only one? And this leads us to a really cool thought experiment. All right, imagine you are this goldfish. From inside your curved bowl, an object moving in a perfectly straight line outside looks like it's following a curved path. But, and here's the kicker, could you, the brilliant goldfish scientist, create a whole system of physics based on your curved reality that perfectly predicts everything you see? Hawking says, absolutely yes. So, whose reality is more real, yours or the goldfish's?
And this is the central point. It's an idea called model-dependent realism. The takeaway is there's no single objective reality that we can see without some kind of filter. All we can do is build models in our minds to make sense of all the data our senses are feeding us. And reality? Well, that's just the model that works.
Let's use a classic example to see how this works. Think about the old Earth-centered Ptolemaic model versus the sun-centered Copernican one. Here's the thing. Both of them could actually predict where the planets would be in the sky. So why did we pick Copernicus's model? It wasn't because it was more true in some absolute sense. It's because it was just so much simpler and more elegant. We picked the better model. Okay, so this whole idea of choosing the best model becomes absolutely essential when we step into modern physics, because that's where our everyday, common-sense reality just completely falls apart. And this brings us to the most ambitious model yet, the quantum multiverse and the hunt for theory of everything. Hawking explains this next big idea, M-theory, with such a great analogy. Think about it. You can't make one single flat map of our round Earth that's perfectly accurate everywhere. You need a whole bunch of different overlapping maps where each one is really good for its own little patch. Well, M-theory is kind of like that, but for physics. So M-theory isn't some single grand equation you can write on a t-shirt. It's more like a whole family of theories that, when you weave them all together, give us the most complete picture of reality we've ever had. And the most mind-bending prediction that comes out of this whole framework is that our universe is just one of countless others. And right here, this is the punchline. The creation of all these universes, it's not magic, it's not a miracle. It is a scientific prediction. According to M-theory, a whole bunch of universes just bubbling into existence from nothing isn't just possible, it's an inevitable consequence of the laws of physics themselves. So this brings us to the final, spectacular conclusion of the book. Now we can take all these big ideas, the end of philosophy's reign, model-dependent realism, and the multiverse, and use them to answer that very first ultimate question, why is there something rather than nothing? Okay, so the argument flows just like this. First, M-theory says there's a multiverse. Second, in this multiverse, the laws of physics can be different from one universe to the next. Third, in almost all of them, the conditions are totally wrong for life. Stars might burn out instantly, gravity's too weak to even form galaxies, you name it. But fourth, and this is key, we are here asking the question. Our very existence acts like a filter. So the whole point is this. The universe doesn't appear fine-tuned for us because some creator designed it that way. It looks that way because in a vast multiverse, it's just inevitable that some universes, by pure chance, will have the right conditions for life to pop up. And of course, that's the one we find ourselves in, because we couldn't possibly exist anywhere else. Spontaneous creation isn't just a wild idea. According to Hawking, it's a consequence of physics. And that right there is the grand design, according to Stephen Hawking. A universe, in fact, a multiverse that just springs into existence from the laws of science all by itself. And it leaves us with this final, profound question to chew on. If the universe doesn't need a creator, what is our place in it all? What meaning do we choose to create in this vast, beautiful, and maybe a little bit terrifying cosmos?